All right, so let's look at our next rule. It's quotient rule. It's going to be similar to the product rule. We're not going to do this kind of investigation that shows that it works. Let's just jump straight to our actual quotient rule here. So let's define our function h of x as one function f, which is our numerator, divided by some other function g, that's our denominator. Then the derivative would be equal to f prime of x times g of x minus f of x times g prime of x. So that part looks sort of like the quotient rule, except it's, looks like the product rule, except it's subtraction instead of addition. And then we also have over, g of x squared. So there's our quotient rule. This case, order does matter in the numerator because subtraction is not commutative. So we're going to have to make sure we get it in the right order. So the first term should always have the derivative of your numerator in it. That sort of makes sense to me. The second term should have the derivative of your denominator in it. Let me take those out of the way so you can see the rule. All right, so again, this just sort of proves the rule. Let's go ahead and use the rule in an example. So they want us to write the equation of tangent line. So first of all, I need my point of tangency. That's going to be g of -2. So I plug it into the function itself. I get 2 times -2 minus 1 over -2 plus 3. That's going to work out to be -5. So our point of tangency is -2, -5. Now to find the slope of the tangent line, that's where the derivative comes in. I need the derivative of g, in which case I'm going to do the quotient rule. So f prime is 2 because the derivative of 2x minus 1 is 2. Recopy the denominator minus recopy the numerator times the derivative of the denominator, which is just 1, all over the denominator squared. I don't need to simplify because in this case I'm just plugging -2 in anyway, so it's just easier to plug it in because there's not too much simplification anyway. That's going to work out to be 7. So that's your slope of your tangent line. So the equation is y plus 5 equals 7 times x plus 2. There's the equation of the tangent line. Derivative gets us the 7 there, the slope of the tangent line. So we're going to say show using the quotient rule that f prime is that derivative. So what's going to happen here is this can get a little messy. So sometimes you should look to simplify first before you do the quotient rule. So what I mean by that is I'm not going to go through this whole mess. You can try this one yourself if you want to practice. So pause the video and go. Or if you want to come back and practice later. Some people are asking me like if they can find more practice somewhere. These are the kind of things you can do. You can pause the video and do the practice, or you can come back at a later date and do this problem. You have the answer there, so you can try quotient rule here and see if it works. We're not going to do that. What we're going to look at is the way that we should do this one moving forward. You have to consider that basically if you do it this way, it's going to get long and messy and a lot of simplification. But if I notice that the top and the bottom both factor and they have a common factor, that can be helpful. You might want to check that sometimes. Okay, it's hard to know like when because if they factor and they don't have a common factor, then this form would be easier. Okay, but if they factor and you notice you can simplify, then you should do that. Let's just say for a second that the top came out to be x plus 3 and they didn't cross off. Then this form here is going to, this form here is going to be much more difficult. So we would use that form instead up here. All right, so, but in this case, they do simplify, so we're just saying, hey, watch out for that sometimes. That you can make your life a little easier by simplifying and now doing quotient rule on this thing, and you'll see that you'll get the same answer you did up here. So if you want even more practice, do the derivative of this function and see that you get the same derivative. All right, so what's the lesson to be learned? If you can simplify the rational function before differentiating, then please do that. So if things cross off, okay, it saves a lot of algebraic mess from happening. All right, now we're going to apply the quotient rule to learn our other trig functions derivatives. We know the derivative of sine and cosine. These other ones are going to be derivatives you memorize, but we're going to now derive them using the quotient rule. So if I rewrite f of theta, I'm going to use x's instead of thetas. So I'm going to call it tan x, but instead of tangent, I know it's going to be sine over cosine. So if I do quotient rule here, it's going to be the derivative of the numerator, which is cosine, times the denominator, which is cosine, minus the numerator times the derivative of the denominator. I put it in parentheses so that negative sign doesn't look like a minus sign. I know it's a times a negative, all over the denominator squared. So up top, what happens is I get cosine times cosine is cosine squared. A negative sign times a negative sign is a plus sine squared. You should recognize that numerator as your Pythagorean identity, so I can make a substitution of 1. Technically, I need to think of it as this, break it into 2 fractions times each other. We kind of skip this usually, but I just like to show you. And 1 over cosine is really secant. So I have secant times secant is secant squared. A lot of times we just jump from there to there. So we just learned that the derivative of tangent is secant squared. That's a rule that we're going to memorize. So for cotangent, you could do the same thing. It's cosine of x over sine of x. There's a similar process here. So what you end up getting for cotangent, the derivative of that is going to be negative cosecant squared x, I think. I better do this one because I don't remember it. I'm pretty sure that's what it is, but I was going to say you can do it on your own, but maybe I need to do it. So let's do it. The derivative of the numerator is negative sine x times the denominator, which is sine x, minus the numerator, which is cosine, times the derivative of the denominator, which is cosine of x, because the denominator is sine. All over the denominator squared. So I can say that this is negative sine squared of x minus cosine squared of x all over sine squared of x. Up top, I can factor out a negative 1. So it's going to be times sine squared of x plus cosine squared of x. So I recognize the top as negative 1 times 1. So it's going to be negative 1 over sine squared of x. So that's going to be negative cosecant squared x. So there's our derivative rule for cotangent. The same things kind of happen down here for secant and cosecant. So the derivative of secant, I'm going to rewrite secant first. So I'm going to get rid of that f prime and call it f. It's 1 over cosine of x. So if I do quotient rule, the derivative of the numerator is 0 times recopy the denominator minus recopy the numerator times the derivative of the denominator is negative sine all over cosine squared. So this first term, 0 times cosine, is just 0. A negative 1 times a negative sine just becomes a sine of x over cosine squared of x. If I break that into multiplication of fractions, I'd have sine squared over cosine of x times 1 over cosine of x. So that means it's going to be sine over cosine is tangent, and 1 over cosine is secant. So there's your derivative of secant. We say that we usually say secant first. Secant theta tan, I should say x, because I used x's the whole way. The derivative of secant is secant times tangent. That's a weird one to figure out. Similarly, you can do the derivative of cosecant. The derivative of this will turn out to be negative cosecant times cotangent. So you can do the same process and see if you get that answer. All right, so now we're going to do some practice problems here. I got to pause and charge the pencil again. All right, so we will do a couple of these examples so we can look at what the simplification process is. So the derivative is the derivative of the numerator times recopy the denominator minus recopy the numerator times the derivative of the denominator, which is just times 1. Oh, that was my eraser. All over the denominator squared. So in the numerator, there's a couple ways you can attack this. In this case, because all these outer powers of the binomials are 1, I can just multiply stuff out, do distributive property. simplify like terms, or collect like terms. So I'll end up getting 2x squared plus 2x minus 4 minus x squared plus 2x, because I distribute that minus sign to both of those, all over our denominator. Sorry, I'm sick, so if I'm sniffling into the microphone, I apologize. Then I collect my like terms, and I'll get x squared plus 4x minus 4x plus 2 over x plus 2 squared. There's our derivative. Let's look at this one and see how it simplifies. So we've got the derivative. I'll use theta this time. So the derivative is the derivative of the numerator, cosine of theta, times the denominator, theta squared, minus, recopy the numerator, times 2 theta all over theta squared squared, which is theta to the 4th. So in the numerator, I could rewrite, I'm just going to rewrite the numerator. I'm going to bring that theta squared out in front of the cosine of theta. I'm going to bring that 2 theta out in front. So it's negative 1 times 2 theta is negative 2 theta. Sine of theta all over theta to the 4th. So what we're looking at here is, you could, I guess, factor out one of these thetas here. So I have a theta up top, and then if I take one theta out, I've got theta cosine theta minus 2 sine theta over theta to the 4th. Getting ahead of myself here. Now that theta is going to cancel with one of those, so it's just going to be theta cosine of theta minus 2 sine of theta over theta cubed. There's our derivative. I should say p prime of theta equals. Moving along, we have sine over 1 minus cosine of theta. So the derivative of the numerator is cosine of theta times recopy the denominator minus recopy the numerator times the derivative of 1 is 0, cosine is negative sine, but there was already a negative in front that came along for the ride, so it becomes positive sine of theta. So then what I'm going to do is distribute that cosine in this part. Oh, I forgot over the denominator squared, sorry. So I distribute that cosine theta, and I'll get cosine of theta minus cosine squared of theta minus sine squared of theta when I multiply those signs together, all over 1 minus cosine of theta, that whole thing squared. This is not sine squared theta. We could talk about why that is if you're not sure. Up top, I am looking to factor even further. So what can we do up there? This is supposed to, oh, I see why, because I forgot to square that. Okay, so then if I factor a negative 1 out of the numerator, I got negative 1 times negative cosine of theta plus cosine squared theta plus sine squared theta. I ran into that not sine theta thing. Let's move that out of the way. Plus sine squared of theta. This part equals 1. Sorry, it's all over this. So I've got negative 1 times negative cosine of theta plus 1 over 1 minus cosine of theta, that whole thing squared. So we notice that 1 minus cosine theta is the same thing as negative cosine theta plus 1. These are the same, so I can cross that out with one of those there. So I end up getting negative 1 over 1 minus cosine of theta. And that's h prime of theta. I'm not going to do it. This one maybe I should do because it's going to have the negative exponent in it. I'm going to say that you are good enough to work through that. I want to see what you come up with. See if you can do it. I get a negative 3x minus 5. When I worked it out, x plus 1 over x squared times x plus 5 squared. That's my challenge. See if you can get that. If you can't, we'll talk about it in class. You can stop me when I come by your desk and see if you can, why you didn't get that. Now we're going to do it from the graph and do this whole thing like we did in the product rule notes. Yeah, same kind of thing with the product rule notes. I don't know if I want to do this. How much time are we at here? 15 minutes. Okay, let me pause it anyway here and charge the pencil. Okay. So, let's see. Is the graph of R increasing, decreasing, or neither? So this, remember, this down here is not a graph of R. This is just a graph of f of x. R is defined as cosine of x divided by that graph. So I know R is going to be increasing if its derivative is positive. I know it's going to be decreasing if its derivative is negative, or neither if its derivative is 0, or possibly undefined, at x equals pi. So my good job here is to find the derivative of R and plug pi into it and do a sign analysis on that. See if I get a positive or a negative. Alright, so let's do our quotient rule on R. The derivative of the numerator is negative sine of x times recopy the denominator minus recopy the numerator times the derivative of the denominator, f prime of x, all over the denominator squared. So now I want to plug pi into that. So we got negative sine of pi times f of pi, which I can grab off the graph, minus cosine of pi times f prime of pi. I could grab f prime of pi off the graph if it's a constant slope on that part of the graph, because then I'll definitely know what the slope of the tangent line is there. All over f of pi squared. I could also grab that off the graph. Alright, so let's see. Negative sine of pi is, so sine of pi is 0, so I've got 0 times f of pi is just 0. This whole part goes to 0 because sine of pi is 0. Minus cosine of pi is what, negative 1? Yeah, and then f prime of pi. So where do I find pi? Well, pi is like right here, so I'm lucky that it's on that constant equation right there, the f prime part. So I then know that f prime of pi is the slope of the graph there, and that's a constant slope. So whatever the slope of that line is, it looks like it's a negative slope, and it looks like it's a negative 2 because it's actually negative 1/2. Sorry, its rise over 1 is 1 over 2. So this is going to be minus cosine of pi, we said was negative 1. Right, I was already doing that part, sorry. Negative 1 times the derivative there was negative 1/2, we said, all over f of pi squared. Now what's interesting here is I don't know what f of pi is, because if I look down at the graph, I don't even know if I'm exactly at pi, and who knows what I have there. What I do know is that it's a negative number and that I'm squaring it, so it becomes a positive number. Up top, what kind of number do we have? It looks like we have a positive times a negative. So, because we have a negative times a negative times a negative, you can look at it that way. We have a negative up top, so it looks like we get a negative number for our derivative there. So r prime of pi is less than 0. So we can say that r of x is decreasing at x equals pi because r prime of pi, or I could just say r prime of x, I should say, is less than 0 at x equals pi. Here's a table one. Again, whenever you get these tables, notice I keep asking you to do that because people want to, the mistake is you're going to want to look here and estimate g prime of x. You're going to use your g values with your x values to estimate g prime. We're estimating the slope of the tangent line, so we're doing a slope of a secant line. 2.5 is in between these two, so I'm doing the secant line between those. So again, we'll skip this, but if you want the practice, you can go ahead and do that. So I'm getting approximately negative 2. Over here, what's the value of p prime of 4? So you have to do your quotient rule. P prime of x is going to be g prime of x times f of x. Whoops, got my pen. Minus g of x times f prime of x all over f of x, that quantity squared. So now I want to find p prime of 4. I can pull all that information off the table. I'm using an x value of 4, so I'm looking on the table at all of these values. I'm pulling off my f of 4, my g prime, all that stuff, so you guys can work on that. It works out to be negative 58. Again, you can pause the video and see if you can get that. So then I'll say since p prime of 4 is less than 0 or negative, the graph of p of x is decreasing when x equals 4, because I said what does this value say about the graph of p when x equals 4? Give a reason. So there's my reason. Alright, now we want to find the value of q of 2. So this one's a little more complex. Let's look at how to do this one. So the derivative of q of x, I just wrote a g though, is equal to, well, now I see two functions times each other. So it's going to be product rule. So I do the derivative of the first, which is 4x, times recopy the second, plus recopy the first, times the derivative of the second. Now, when I go do the derivative of the second, I have a quotient rule for that. So you can kind of combine the rules. You can start to see it. They're going to kind of work together. You can have multiple rules in one problem. So inside of here, I've got to do my derivative rule. So f, the derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator, all over the denominator squared. All right, so then they want us to find q prime of 2. So you got to plug 2 in everywhere. So 4 times 2 times f of 2, g of 2, plus 2 times 2 squared. And I'm going to let you do it because I am the teacher. So sometimes that pays. So you can pause the video here and do this. I get negative 72. You see what you get. Find the equation line tangent to the graph when x equals 3. All right, so tangent line. First I need the point of tangency. So that's going to be v of 3. If I plug the x value into the function, I get the point of tangency. So I'm getting 9 over whatever g of 3 is from the table, which it looks like it's negative 3. So I get negative 3 for that point. So 3, negative 3 is my point of tangency. Slope of the tangent line, that's going to be finding v prime of 3. So first I need v prime of x. It's going to be the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. We're going to plug 3 into that to get our slope. You're going to pause the video and do that. See if you get negative 7. That's what I get. So I can write the equation of the line as y plus 3 equals negative 7 times x minus 3. Thanks for playing.